Hello and welcome to this first video in our lecture on digital envelopes and pseudo-random number generators. First, I want to review some of the applications of public key crypto systems that we have discussed already in this course. So the first application is that of digital signatures. So remember, the goal of a digital signature is both to authenticate the sender and also check the integrity of the message. So starting with a message M, we're going to pass it through a cryptographically secure hash function, say SHA-2 or SHA-3, and this will produce a message digest, a hash code, that we're going to then feed to a public key crypto system or encryption algorithm, for example, RSA. And this then is going to produce a signed copy of the message. So that was what we discussed at the time of our digital signature presentation. Now we have three other kinds of application. They're all related to this problem, to solving this problem of key management and how to distribute keys among parties in a communication scheme that requires encryption. So the first application in this context will be the secure distribution of public keys. This is what we discussed in a previous video, including the PKI or public key infrastructure. And the main mechanism here in that context was the public key certificate. The third application of public key crypto that we have discussed before has to do with the problem of securely distributing symmetric keys to be used for symmetric crypto. And the algorithm we discussed in that context was the Diffie-Hellman algorithm. And remember that we discussed the color mixing analogy when describing this algorithm, where we would be dealing with very big numbers, including prime numbers, and then we would mix them by using exponential modular exponentiation operation. So these are the three applications we've already discussed of public key cryptography. And in this video, I want to discuss a fourth and new one, that of digital envelopes. So imagine a scenario where a sender wants to send a confidential message to a receiver, but the sender and receiver did not share a private key ahead of time. So this is a scenario where a digital envelope becomes useful. And the name of that mechanism comes from the following analogy. Let's say you want to send a postcard to someone through the regular mail, but you don't want the mailman to read the content of your message. So instead of sending a plain postcard, you can either put the postcard or the letter inside an envelope and then seal the envelope, this way reaching some kind of confidentiality. So this is the idea of a digital envelope, where we do the same thing but in a digital mechanism. So assume that Bob, the sender, wants to send a confidential message to Alice, the receiver, and they do not share a symmetric or private key before initiating this process. So on the next slide, we're going to see the details of the mechanism for digital envelope. So on this side, we have the sender, and the sender is going to perform a sequence of steps. So first, there is a setup step that will include three components. First, the sender is going to prepare the message that they want to send to the receiver. then the sender is going to generate a random sequence of bits to be used as a symmetric key. And finally, in the setup step, the sender is going to obtain the public key of the receiver, presumably through a public key certificate. After these three preliminary steps, the sender is ready to prepare the digital envelope. The first step is going to take the message and to encrypt it using the symmetric key that they just generated. The result of this operation will be an encrypted message that will be sent to the receiver. But since the receiver does not know the symmetric key, that key has to be sent together with the encrypted message. Since we cannot send the key in the clear for attackers to discover, we're going to, in the next step, encrypt that symmetric key using the public key of the receiver. So now we have, and the output of this operation is an encrypted symmetric key. So in the final step, the sender is going to combine together into a digital envelope both the encrypted message and the encrypted symmetric key. And so this digital envelope is ready to be sent to the receiver. So that's the first half of the mechanism. The second half is performed by the receiver. So the receiver is going to receive the digital envelope. And the first step will be to separate the encrypted message from the encrypted symmetric key. And recognizing that they're dealing with a digital envelope, the receiver is going to use his or her private key to decrypt the symmetric key. So this is the next step, resulting in a decrypted symmetric key, namely the original key that was generated by the sender. Now, with this key, the receiver is ready to decrypt the message, and this will yield a decrypted message that the receiver can then read. So, this is the entire mechanism for the digital envelope application of public key cryptography. So, I want you to pause the video, think about how this mechanism works. Does it really guarantee confidentiality between the sender and the receiver? And you also want to think about the authentication aspect. Who is authenticated to who in this mechanism? So to summarize here, with this digital envelope mechanism, the sender, Bob, is pretty happy and to believe that Alice, the receiver, is the only person beside himself who can read this communication because only Alice can decrypt the symmetric key and therefore decrypt and read the message. So in that sense, we have confidentiality enforced for this message. And also, we can see that since the sender received the receiver's public key as part of the public key certificate, the sender is convinced that only the receiver can read the message. In other words, the receiver is authenticated to the sender. So that's the big picture for this digital envelope mechanism. And before we wrap up this discussion, I want to step back and discuss this mechanism by comparing to a couple other mechanisms or protocols we've discussed before. So the first thing I want to do here is to compare the digital envelope mechanism to a previous protocol that we discussed on, I think, in a previous lecture, and it was this protocol displayed on this picture here. So let's compare this protocol with this digital envelope mechanism. So remember that in that protocol, so the role, notice the role of Alice and Bob's are exchanged, where Alice was the initiator of the communication here. So in step number one, Alice would have obtained the public key of Bob. She would have used it to encrypt a key K that she would have randomly generated. And then she would send this encrypted key to Bob, who could then decrypt it using its private key. And therefore, at this stage, the key K is shared by both parties. And that key is used later on between the two parties to send encrypted data among themselves. So let's compare this protocol with a digital envelope. The first thing to notice is one similarity is that both approaches are hybrid algorithms. In other words, they both use public key cryptography to encrypt a short fixed sized data, in this case the key, and then in a second step they use symmetric crypto to communicate confidentially. So in that sense, this is a hybrid protocol, and of course, so is the digital envelope mechanism, since we use the public key of the receiver to encrypt the symmetric key, and then we use the symmetric key to encrypt the message. All right, so in that sense, they are both hybrid. In terms of authentication, and this is a question I asked you earlier about this protocol, who is authenticated? Well, assuming that Alice got the public key of Bob in a certificate, then Alice is sure that this is Bob's public key. So in that sense, Bob is authenticated to Alice in this mechanism. On the other hand, Bob has no idea who is communicating with him, since Alice here is not authenticated to Bob. And again, this is similar to the digital envelope scenario in which the sender is not authenticated to the receiver, but the receiver is authenticated to the sender. So this is what they have. These are two features that these two approaches have in common. There's one difference though, and so this is the same for both protocols, but here is a difference which is somewhat significant. And the difference is in this protocol, it's really a two-step process where first we are using public key cryptography to generate a key K, and second, we're going to use that key in a sequence of following messages that happen later on. By the way, uh, this sequence of messages is usually called a session, and therefore this key that is being shared is called a session key. So that key is not going to be used forever in every communication going forward between Alice and Bob. It's only going to be used for a small number of communications as part of a single session. So the main difference here is that in the digital envelope, we do not have a session key. What we have instead is something we could call maybe a one-shot or one-use key. So what I mean by that is in the case of digital envelope, we did not use this mechanism of first sharing a key and then using it later on for a bunch of messages within a session. Here, there is only one message ever sent from the sender to the receiver. And in that message, there was both the key and the encrypted message. So here, the key, the symmetric key that is shared between the two parties, is used only once. So a standard application of this would be for sending encrypted email. Let's say that you had an address book full of your previous contacts, and you would include in that address book the public key of those contacts in their certificates. And let's say one day you wanted to send an encrypted email to one of those contacts. Well, what you could do is you could use this mechanism to send a single email, encrypted email, to that contact using their public key. And this is an application that's actually being used by a famous encryption program called PGP. So PGP stands for Pretty Good Privacy. It's a well-known encryption application. It is in particular used for sending encrypted emails, and PGP does use the digital envelope mechanism for this application. So, to wrap up this discussion, I want to discuss this digital envelope mechanism with respect to another application that we briefly mentioned earlier, which is the digital signature. I want to make sure you do not confuse these two applications. Remember that a digital envelope is used for confidentiality in a one-shot communication, whereas a digital signature is not used for confidentiality. It's used for authentication of the sender and also for enforcing the integrity of the message. So these are two completely different applications of public key crypto, and I want you to keep them straight and not confuse them.